Hello, I'm Paul Orselli, and I am super happy to be joined all the way across the waves from the UK by Dan Bird. How are you today, Dan?
Good morning to you, Paul. I'm very well today. It's a lovely sunny mid-afternoon or early afternoon here.
Where are you zooming in from today?
I am zooming just above Bristol in a small little village called Minchinhampton. That is part of an estate where they have cows roaming loose on the ground outside. So you have to avoid the cow jams in the morning. The kids love it. They kind of get delayed in the morning by cow jams.
Well, we're not going to talk about cows or the things that come out of cows today. I don't think, who knows. But so Dan, what's just one thing about exhibits you'd like to share with people?
Okay, so I want to share something, but I have also sent you a little gift that I thought might be something that we could talk about. So there is a little box there. So I'd like to open your box.
This came via international mail, and when I opened it up, look what Dan sent me, a 3D magnetic copy of the POW logo. All right.
Yeah. So I love building and designing, creating exhibits, and increasingly we're using more and more 3D printing because for us, we like the fact that we're not cutting huge slabs of material and throwing half of it away. We like the fact that we can easily reproduce parts. So in terms of our development process, 3D printing has completely transformed how we do our job. And I've got a few slides that I can kind of show you. Your POW logo arrived to me as a graphic file that I stole from your website. I simply drew around it to create a 3D model. And then I created what's called a print file. And that's the print file that controls. A 3D printer is really a hot glue gun on the end of a robot arm. And the robot arm follows some instructions and can build things up in layers. And it's really quite smart. I discovered 3D printing probably about 4 years ago. And it's one of those areas that's moving on so much. So I know a tiny amount, but if you want to know more, go online. There are millions of videos that explain how it all works. And there's plenty of links. My very first.
I was going to say, since we're on YouTube, there will be links. We can include references and links in the description below. So that will be great.
Okay, so we will put together some links. And I wanted to share with you my very, very first 3D print. This is, as you may be familiar with, this kind of structure here. So the idea was that we wanted something. I was very lucky to do a fellowship with the Wellcome Trust, which gave me 2 years of non-working away from the love and wonderful working with 25 people in a workshop. I was all of a sudden abandoned on my own, working from home, and I needed to develop some exhibits. And I discovered 3D printing. I bought a printer, but then realized you need to be able to code or write the program to put the print together. So this was my first thing that I printed. And the big thing here is that you've got two colors, and your logo actually has exactly the same thing. And 3D printers take basically a big reel of, this is what you buy. So it comes in lots of different colors and different materials. We use something called PETG, a particular sort of plastic. So the same sort of thing a pop bottle is made out of. So it's very, very durable. That is taken, heated up, squirted out into various things like your logo. What we will do now is very quickly show what I did to create your logo. So we're now in what's called the Slicer software, and this takes the file, which is here, into the computer, and this is the file. What we now do is orientate it the right way around, and we're going to print it on the stage. We click slice, and the computer works out what the robot arm needs to do to actually, you can just about see these lines here. Every line there is a point where it will extrude the material. And then you might notice you've got a yellow background with black writing. And so what we can do is actually go down at that point, say, printer, please change the color. And what will happen when it's printing, it will say, I'll do the first bit and I'll change the color. But also we were very sneaky and we put some magnet holes inside the model. And these are just little small cavities. And what happens is you can actually say, just right there, another stop. So rather than actually change the color, it wants you to change the color to a different color. All I did was I kept it yellow. And so the bottom half is yellow, the top half is black. And that's how we take a 3D model and create what's called a path for the 3D printer to actually make your object.
Wow, that's awesome. So in this logo, 3D logo, there obviously are magnets inside since it sticks to my refrigerator. So did you just stop the 3D printer and then stick the magnets in and then continue along, so it's the magnets are just embedded inside?
Exactly right. So we know we have some health challenges with using these very strong rare earth magnets in exhibitions, because if people swallow them, particularly 2 magnets, it can be really, really bad and dangerous. So actually finding a way of positively 100% anchoring the magnets away from the public. We've created the logo, we've printed it out, and the next thing is, well, 3D prints are quite lightweight because they're hollow. And this actually allows you to do a whole bunch of things. The Guess What exhibit is an exhibit we created where you can lift some flaps. And there are 24 little square panels, each containing really nice objects that people can touch. And we wanted to create an exhibit a bit like the Guess Who game, where you have to guess, oh, it's a guy with a big hat and a big nose and glasses. So we created the game so it was quite vertical. And we've kind of discovered that the flaps needed to stay up, and how we were going to do this. And 3D printing for us allowed us to create a lightweight, durable flap with a magnet encapsulated. So you can lift the flap, it stays put, and then you can also knock it down. And for us, that exhibit actually provoked conversation and really detailed looking at these natural objects that was fantastic. But the 3D printing and that allowed us and enabled us to create something that would have been very difficult to create using other techniques. I've seen so many lift the flap exhibits using a kind of standard door hinge and maybe an inch thick piece of oak that you can put your fingers behind and really hurt yourself quite badly. So I wanted to make sure this was my very first lift the flap exhibit with 24 flaps. And I wanted to make sure it was as safe as possible. So there were absolutely no finger traps. It's durable, it's wipeable for COVID, you can clean it, really durable plastic. And that worked really well. So we kind of moved on from that and we thought, what else can we make? And another thing we actually make is a gears exhibit. So each of the gears are 3D printed. So again, the property of 3D printing, I've seen lots of these cut from foam, or sometimes they're cut from flat sheets of material. The advantage of 3D printing is that it's hollow. And so when you have gears that are spinning around really quickly, they can contain lots of energy and potentially you can hurt people. So with lightweight gears that are durable, printed in different colors, the back panel of the exhibit also contains a whole bunch of other things, including a worm wheel, and that was 3D printed. So there's a black gear wheel, a big gear wheel that rotates with some bells, and then a worm wheel that spins. And that worm wheel, to give you an idea, took about a day and a half to print. So 3D printing is not fast. I think if you're looking for a 3D printer in your building, there's probably one gathering dust in the makerspace somewhere, where people have thought it was a really great idea to buy one at the start, but actually they've realized it takes too long, difficult to use with the public. But there's a way you can resurrect that printer and find a way of using it in another way in your exhibit development team.
Well, I think it's interesting. We were talking before we started the recording that 3D printer, of course, is a tool, you know, like a screwdriver, but it still has a cool factor different than a screwdriver. But I think it's interesting, you know, as you became more acquainted with what the 3D printer could do, then that becomes a tool in your toolkit, and it starts impacting your designs and your thinking. So that's great.
Yeah. So this is another thing that we made, which is we make a video microscope, and we wanted to be able to use regular glass slides on the exhibition floor, and so we created this kind of puck that still had good optical quality because the glass was actually visible top and bottom, but you didn't have any of the sharp corners. Now, if someone really wants to, they can use a key and break the glass, but this is a kind of using a laser cut piece of acrylic, 3D print, and then we even have a little RFID chip with the coil there. So when you put this in the microscope knows what you're looking at, and it can actually create some prompts for looking a bit further at particular parts. So we made that first. And the problem with 3D printers is that my printer is quite small. And a client really liked the slides, but they had a real problem with actually, they kept on going missing, because I've got to say it's quite nice object to take away.
An attractive object.
An attractive object. So we tethered our attractive object, not with a piece of string, but we actually created this using dovetails. So you took a woodwork kind of analogy of using a dovetail to join parts together, and that created a turntable with different slide holders on it, again with the chip, so you knew what you were looking at. And that's another example of our sort of use of 3D printing. I went to the workshop and picked up things that I could find, and this is something we're doing actually this week, which is a very popular part of a water exhibit that we make. So very lots of water areas have this. It's a pole, a post with some slots in it, and then you drop a dam, and you can create a dam, and they're arranged in a triangle arrangement. The thing we've actually added to this that I've not seen anywhere else is actually a water wheel. So this is half a water wheel. So we print it in half because we want to put and press fit a bearing inside to make it run really smoothly. But we also want to be able to take them apart to be able to change the bearings. So you, rather than print them in one piece, you print them in two halves, bolt them together. There's an axle that sticks at one side, and that drops into the little slot in the top. Now I put the slot there to hold the water wheel, but actually when you're dropping the plate in, having a wider top makes it much easier to kind of move the plates around. So the water area using multiple parts like this, because once you've completed the design, you just press print, and you can print as many as you can fit on the bed at the same time. It's good outside, so the material seems to last pretty well outside, and you've got huge potential to change things once they're on site, but also tweak. If that radius isn't quite right, you can change it and reprint. So in terms of like a development, quite often we welcome new exhibits into our centres that have been developed, but it's sometimes the first time they've really been tested together with the technical packages, the software, and it's the first time they put in context. And we know how exhibits change depending on where they are, but 3D printing actually, if you design in from the start the ability to make small changes, your development process can actually extend out into post-delivery when you're looking at actually changing certain small things after people have used it.
Well, I think that after everyone sees this video, they're gonna want to resurrect their existing 3D printers or buy new 3D printers or contact you to ask all kinds of questions about 3D printers. So I think that's great. And as I mentioned, we'll put links or references in the description below, and we'll put your contact information. I don't want to open the floodgates, Dan, but I think that's good. And this is great, you know, using this video series, and I start everybody off with the same prompt. What's just one thing you want to tell us about exhibits? And I didn't really expect 3D printers to come up. So this is great. And as a bonus, I get this cool magnetic logo to play with. So that's great. Thanks, Stan. I really appreciate you taking the time today.
Great to talk to you. Bye, Paul.